Good afternoon and welcome. My name is Tom Carpenter and I'm the CTO here at CWNP. So we're going to go ahead and get started today with this topic, which is a foundations topic. However, these foundational concepts are absolutely essential to implementing an effective wireless LAN. If we don't know how RF works, we can't make RF work the way we want it to. And so it's very important to understand these foundations. Therefore, even if you've been around Wi-Fi for a while, I'm sure you'll hear some tips and tricks that will help you better optimize your networks as well. Okay, so let's talk about our agenda for today and what we'll be talking about. First of all, we're going to be looking at RF basics. So before we get into the 5 RF fundamentals, I do want to review some basics with you to make sure you have the terminology down. Then we'll get into the 5 RF fundamentals, which are channels, behaviors, measurements, interference, and analysis. And we'll look at those one by one. So first of all, RF basics. What we need to understand is frequencies, waves, and radios. The frequencies are the specific locations within the RF spectrum that we actually use to transmit our data or to pass signals on. The waves, of course, are the actual medium that we manipulate in order to modulate data and therefore transmit data. And then the radios do the transmission. So let's talk about this a little bit more. First of all, when we look at frequencies, the two primary frequency bands that we use for 802.11 wireless networks are the 2.4 gigahertz frequency band and the 5 gigahertz frequency band. Now, 2.4 gigahertz many years ago kind of won a battle because of being first to market. That is, with the original 802.11 standard that came out in 1997, sometimes called 802.11 prime, did not specify any operations in 5 gigahertz. It only specified operations in 2.4 gigahertz. And since that was first, these were the devices that existed. We then had a rolling effect that has stuck with us to this very day, and that is that because 2.4 gigahertz client devices already existed, even when APs came out that could support both 2.4 and 5 gigahertz, we still kept supporting 2.4 gigahertz because 2.4 gigahertz clients existed. And so therefore, we still find ourselves in that space today, which is not a good space to be in. 2.4 gigahertz is very cluttered. Some have said in recent months that 2.4 gigahertz is dead. This is, of course, completely untrue. How can you say that something that is alive and utilized more than anything else is dead? It's not dead, but it's certainly crippled. It's crippled because of the fact that so many devices operate there, not just our wireless networking devices, but many other devices as well. So 2.4 gigahertz is not an effective band for enterprise wireless LANs when we have control over the client devices that are going to be used. If we can dictate that 5 gigahertz clients will be used, then we want to use 5 gigahertz clients. Why? Well, we'll see later. There are many more channels in 5 gigahertz because we have much more frequency space. So the first thing to realize is that the frequencies matter. And the frequency is really just how often an RF wave cycles per second. So how many waves per second are we creating? 20 hertz would be 20 cycles, 900 megahertz would be 900 million cycles, 2.4 gigahertz is 2.4 billion cycles per second. So higher frequency waves have shorter wavelengths and lower frequency waves have longer wavelengths.